Hi, these questions are in the Homework 9.3 packet. You were just supposed to do the front page of that Homework 9.3 packet for homework last class. But then in class, we started going over some of the other questions in the packet that I called some of the extra honors examples. We got different spots in each class. So the 4 problems that I intended to do in class, I'm going to go ahead and do on the video now. If I already did it with you in class and you understand it, you can just skip to where we didn't get to. But if you weren't here to do them at all, then write down as I talk through the next 4 questions. Write those down, and then there will be 4 questions left in the packet that I do want you to try on your own by the time I see you in next class. So this first one we're going through is when the center of rotation is not the origin. And you can see here it says graph triangle ABC with vertices A, B, and C, and they give you those ordered pairs. And they're asking us to do a rotation of 90 degrees. But then what's different is it's saying a rotation about point A. So instead of about the origin, it's going about A. So that's the key thing we need to pay attention to. So let me actually make this a little smaller. All right, so let's go ahead and plot our points first. So I can see A is at 1, 1. I like to go ahead and say where the origin is too. Sometimes it kind of is easy to lose track of where it is. So sometimes I'll put a 0 by it or a star there or something. B is at 3, negative 4. And C is at negative 2, negative 1. Okay, so I'm going to go ahead and draw that original triangle. All right, so here's what we're going to do. If we're rotating at about point A, I am going to put a little star at A so I don't forget that that's where I'm rotating it about instead of the origin. Okay, now if I think about rotating point A about point A, then my new A is just going to stay at the same spot. So I'm going to go ahead and call A prime right by this point as well. And so I know if A isn't changing, it's still at the point 1, 1. So that's the easy part. Okay, for B, I want to see how far away B is from point A. Okay, so if you think about it, then I can see how far am I going this way and how far am I going this way to get to B. And I'm going to write that down. So you can see here, I just went 2 to the right. So to get from A to B, I went 2 right, and then I went 1, 2, 3, 4, 5 down. Okay. And so since it's a 90-degree rotation, then you're going to turn the paper 1 turn to the right. Okay, so turn your paper 1 turn to the right, and then go 2 to the right and 5 down, not from the origin, but from point A. And when you do that, you should end up right here. It actually goes off the graph 1 spot, but that's where we should end up, and that's the new B. Okay, now we need to do the same thing going from point A to C. Okay, and you can see from A to C, we're going 3 to the left and 2 down. So I'm going to write that 3 left and 2 down. Okay, and so again, I want to take my paper, I want to turn it 1 turn to the right. It's still giving me a counterclockwise rotation, but I'm turning my paper 1 turn to the right. And when I do that, I'm going to go 3 left and 2 down, not from the origin, but from point A. So 3 left and 2 down is going to give me a point over here. And that's my new C. And then since I have a lot of red there, I'm going to use purple to connect my dots. So now I'm connecting A prime, B prime, and C prime. And there is my rotated triangle. And now I need to go ahead and name what these new ordered pairs are. So I can see that B is at 6, 3, and C is at 3, negative 2. Okay, let's go ahead and go down to the next one. The next one is an honors type reflection question. So on this one, so more reflection practice. So on this one thing I ask you to do in class is if there's something still written here on your paper, cross that out. Okay. And I also need you to change point C right here to 0.24 if I didn't have you do that in class. Okay. So I think on your paper it said -2. Please change that to a +2. And I think it had a 1 there, and I want you to change it to the 4. I kind of made the changes and made all the copies before I worked it out and realized it didn't work very well on this particular graph. So I made some changes. What we're doing on this one is, you can see here, it's a reflection with the capital R, and you can see y is equal to x is the line of reflection. So that's the part that's a little bit different than before. All the other reflections we've done so far have been either a horizontal line or a vertical line. And now this one is going to be a slanted line. So that's why it's a little different. And we know we're reflecting triangle ABC, and then we're writing the new ordered pair. So let's start off with plotting the points A, B, and C. I'm going to put a 0 here at the origin. So A is at 1, 2. B is at 2, 3. And C is at 2, 4. Okay, so now if I go ahead and draw that triangle, looks a little weird, but it's a triangle. And now I think I'm going to actually move that B so it's not in my way. I'll put it right there. All right, so now I want to graph the line y is equal to x. If you think about the line y is equal to x, if you're having a hard time thinking what that graph would look like, you can always make an XY chart when you're graphing. So, any number I plug in for x, I can solve and figure out what y is. So if I put 0 in for x, I get 0 for y. If I put 1 in for x, I get 1 for y. 2 in for x, 2 for y. So if I plot those points, I can see that this line is a slanted line that goes to the origin, and it basically has a slope of 1. So I'm going to just make a dotted line here. I'm going to go ahead and label it y equals x. And now I need to do my reflection. Remember, what my answer should look like is if I folded my sheet of paper along the line of reflection, then the two figures should match up exactly. So I'm seeing how far, A is from the line, the right angle distance, B is from the line, and C is from the line, and I need to take it that far on the other side. It's just when it's slanted like this, it's harder to just, count the spaces like you would if it was a horizontal or vertical line. So what actually happens, it's called an inverse that you'll talk more about in Algebra 2. But what happens is you're just switching the places of the x and the y, and that's what gives you the mirror image. So for these ordered pairs, I'm going to write the ordered pairs first. If I switch if this is an x and this is a y, and I want the inverse of the mirror image, I can just flip those two. And so I end up with the ordered pair 2, 1. Here for B, I'm flipping the x and the y in 3, 2, and flipping the x and the y. So I get 4, 2. Okay, the signs aren't changing because in my equation over here, y is equal to x. And so I don't need to make an adjustment on those changes at all. So now if I go ahead and plot these points now, switch color to blue. Then I can go 2, 1 for my A prime. I can go 3, 2 for my B prime. and I can go 4, 2 for my C prime. If I go and get those connected, then again, double check yours. Make sure that A is the same distance away from the line of reflection as A prime, B is the same way as B prime, and C is the same distance away as C prime. Again, my red line looks a little bit off from my points, but I think you get the idea. Again, if you fold your paper along the line of reflection, you should see those points matching up. And we already have the ordered pairs filled in at this point. Okay, now on the next page, this is on translating circles and lines in a worksheet. So if you look at that equation of the circle, I think from asking people in class, most people were not familiar with that formula, and that's okay. We're going to do more with circles later this year, and in future math classes, you're going to do more with circles. But this is just giving you, kind of relating it to the translations that we were talking about before. And so I think you'll kind of understand it enough to be able to do that. And at least get you familiar with the formula so that when you use it later, you'll know what's going on. So if you look at this formula, it says x minus h squared plus y minus k squared is equal to r squared. And then you can see over here, it says the center is hk. So really what happens here is the h part of the center ends up being the opposite of this number right here. Okay. And what ends up being the k part of the center is basically the opposite number of what is here. It's the same number, but a different sign. And then the radius, we're not really doing anything right now with, but that's how you get the radius. That number is r squared. So say that number was 25, then I would know the radius of the circle is 5. Okay, so if we come down here to this first one, it says we're doing a translation of 0, 5, which means we're going to go 0 in the x direction, 5 in the y direction, shifting it that much. And it's showing this is our circle. So the first thing we want to do is write what our center of the circle currently is. And I can see that if that says positive 4, then I know my center number is negative 4. If this says negative 1, I know my center value is 1. It's the opposite of those. Okay, now I just need to do this translation. So we just saw that the translation says 0, 5. And so I want to add 0 to my x value, and because it's positive, and then 5 is positive, so I'm going to say plus 5. Okay, and that's going to give us a shift in the center. Okay, so the center after the translation is what I'm going to call this. Then you can see my new center is going to be negative 4 plus 0 is still negative 4, but 1 plus 5 is 6. Okay, so really the circle just shifted up 6 spots on the coordinate plane. And now I just need to write what my new center is. So if I plug this center into the equation of the circle formula, I'm going to have x minus is part of the equation, and negative 4 is what I'm plugging in. And then I've got to square it, plus y minus is part of the equation. 6 is what I'm plugging in, and that's squared. And it's equal to 48. That didn't change. Okay. The only thing I would do from here is just clean up this negative. I mean, you can just make both of those a positive if you want to. I'm just going to rewrite it so people can see what happened. Okay, and that would be my equation of my circle. Okay, so I would like you to try number 2 on your own. Follow the same process. It should be pretty similar. All right, now if we look down here, this is the last one we're doing together. And then there's 2 more on the back page that you will do on your own. That again, you can see examples for that we just did. Those are rotations on the back page that are rotating about a point other than the origin. So on number 3, here you can see that it says find the new equation of the line after the translation. So when it says a new equation, the two equations we might deal with are slope-intercept, which I'm going to go ahead and write down, which is y equals mx plus b, and the point slope formula, which is y minus y1 is equal to the slope times x minus x1. All right, so the first thing we're going to do is name a point on the pre-image. So 1 point on pre-image is, I can basically use this number right here, the y-intercept. If you were graphing this, you would say, that number that comes after the x is the y-intercept, and you would graph the point. You'd go down on the y-axis 3, and that actual point would be the point 0, -3. So that's our y-intercept, okay, or b value. Okay, now you can see what's going on here is, let's switch colors. You can see that we are doing a translation, and you can see up above here that it's, saying 4, 0. So I'm going to go ahead and write that here. Here's our 4, here's our 0. That's our x direction, our y direction. But what we're going to translate is this point that we know for sure is on that graph, which is 0, -3. So if I add 4 right here, and I add 0 right here, then my new point ends up being 4, -3. And this ends up being a point on the image. That is our new point after we translated, the pre-image is where we started, and now this 4, -3 is going to be a point on the actual image. So I'm going to say point on image. Okay, and I'm going to label it x1, y1. Okay. Now, if I think about the slope of the lines, okay, I can go back to this original equation up here and see that the number in front of the x is the slope. So I'm going to say slope of both lines, or the m, if you want to think about that, is equal to 6. Okay. So again, the original line had a slope of 6, and this new line is also going to have a slope of 6. Okay, we haven't changed that. We've just shifted one of the points somewhere else. Okay, so now we just need to write an equation of the line, and for an equation of the line, we're going to use the point slope form. And in point slope form, if you look up here, we need to fill in x1, y1 with a point, and we need to fill in the slope. Well, we have all of those things. Here is our x1, y1, and here is our slope. So that's what's getting plugged in. So I can say y minus y1, which is -3, is equal to the slope times x minus x1, which is 4. Okay, and they didn't really specify what form to put the final equation is. This would be point slope form, but I think a lot of times in a problem like this, they're going to have you put it in slope intercept form, which means you just need to end up getting a y by itself. So if I go ahead and solve to get y by itself, then I'm going to go and clean up this first part and say y plus 3, and then I'm going to go ahead and distribute this 6. So that gives me 6x minus 24. And now to get y by itself, I can just subtract 3 from both sides. and get 6x minus 27. And that would be my new equation of the line. And again, that whole line got translated for 0, but it still has the same slope. It just got shifted. Basically, it just got shifted 4 to the right. Every point on the line got shifted 4 to the right. But we could do it without actually graphing it. If you want to graph the original line and then graph the new line, then you could certainly do that. And number 4, you're going to try on your own, following the same process. And then you can see over here, you are going to do a rotation of 1 knot at the origin. And you can see here it's a 90-degree rotation about point A. So it's similar to one of the first ones that we did, but it's just different points. So you're going to try that one on your own. And then you're going to try this one, which is also a 90-degree rotation, but it's about the point -1, 1. It is not point A, B, or C. You're using the same A, B, and C value that's up above, okay? But you're doing a different rotation, okay? So same as what we just talked about, except for instead of referring to the origin, you're referring to the point -1, 1 to get that done. All right, and hope it goes well. So try those, and then we'll go over those another day. Thanks.